Let's take a look at how we can leverage existing DWG data to create robust and feature-rich 3D models inside of Inventor LT. Let's start out by opening a DWG file directly inside of Inventor LT. From here, we can take all of the pertinent geometry and dimensions that we need to create a 3D model. We'll simply take that geometry from our DWG file and place it inside of the sketch environment inside of the Inventor model. Here we can take this geometry, move it and place it wherever we see fit. In this case, we'll simply align it with the origin inside of our sketch environment. And now we can clean up this sketch. You'll see inside of this sketch we've got some annotations and some dimensions. These are now parametric dimensions inside of the Inventor LT modeling environment. So changing dimensions will update geometry. We also have some just annotations. These annotations are just user annotations or notes that were placed in the DWG file. I'm going to simply remove those because if they're not parametric inside of the modeling environment, at this point in time, I don't necessarily want them. If I can't trust them to be true and accurate and parametric, I prefer not to have them inside of my sketch environment. So let's go ahead and remove them. Once we've cleaned up our sketch in our part environment, we can now take this DWG information and use it as the underlying guide to create this 3D model. So with our extrude command, we can take that existing sketch and select any profiles from that DWG file to represent our new 3D shape. Once we get all the profiles selected, we're able to use the side view of that DWG file and that parametric dimension to define the thickness. Now we want to use that geometry over and over, so we can simply share that DWG file or that sketch inside of Inventor. So any additional extrusions we make, like the center hub of this pin, again we can use that 22.5mm dimension from the side view. Now from here, I want to take a look at some of those holes. Now the hole callout in the DWG file was an annotation or a hole callout, and I want to make a little bit more intelligent of a hole inside of my modeling environment, and that's where Inventor becomes really powerful, or the use of Inventor LT in a 3D modeling environment, because now I have utilities and tools like a hole tool, where this hole tool can go through and I simply select the type of hole, in this case a tapped hole through all, and I can choose from a standard library of hole sizes. So in this case, simply picking an M7 will give me an M7 tapped hole. And just like in 2D environments where you can array or pattern, in 3D environments I can pattern existing features, in this case a circular pattern, equally spaced, 3 holes throughout this stop pin. Now to finish off the model, we'll apply some features like chamfers and such. So here we have a fairly complex 3D model done quickly and easily. But now with the 3D, we can also add additional information outside of just the model. In this case, we can add data like what material it is. So in this case, if we make it aluminum, it now has the density of aluminum, which will in turn give us the proper weight of aluminum. So just simply viewing the eye properties in this part, we can see all the physical properties. In this case, I can see the center of gravity, the weight, things like that. Now we want to start documenting this. Now we want to create another DWG file, but this DWG file will be inside of Inventor LT. And the beauty of this is it's an associative model back to the 3D part, but this drawing as well is a DWG file, which means it can be opened inside of additional Autodesk products like AutoCAD or AutoCAD LT. So as we populate our views, we can start seeing the ease of use and the quickness of which we can create these drawings. And essentially, once you have a 3D model, you get the drawing for free. But it's not just a basic 2D DWG like we saw that we imported, but I can start putting in isometric views that are shaded. And those are views you typically aren't going to do in a 2D product because of the amount of lines and the complexity of it. But I want to create a more feature-rich DWG file. And in this case, I'm going to create things like align section views, detail views. I really want to give the end user a very, very detailed and very feature-rich drawing. And the reason for that is, well, one, it's not just because I can, but because it's so fast and easy. So a lot of these manual tasks that you'd be doing inside of your typical 2D workflows, we can automate with Inventor LT. So in this case, just menial tasks like center lines and center marks. I can have Inventor LT automatically place those in all the views I specify. And once that is done, I can create additional views. And those additional views could be detail views and cutaway views. All of these things can be automated inside of the Inventor LT environment. At this point, we've got all the basis for our DWG file. What we'll talk about in the next session is how we can take and complete the detail view in all the detailing of the DWG file, and then communicate this outside the organization with the DWIF, or the design review tool, and round trip and mark up that document and bring it back inside of Inventor LT. I hope to see you with session 2.